Hello everyone and welcome back to the course. In today's lesson, we are going to learn how to use the functions sine, cosine, and tangent for finding angles and sides of triangle. Let us consider the following right triangle and the given angle theta. Now, opposite to that angle is y, and the adjacent side of that angle is x. Now, the hypotenuse is given by r, but by using the Pythagorean theorem, we know that r squared is equal to x squared plus y squared. Therefore, r is equal to the square root of x squared plus y squared. Now, if we use the information that we learned in the previous lesson, we know that sine of theta is equal to y over r, whereas cosine of theta is x over r, and tangent of theta will be equal to y over x. Now, let us suppose that the angle theta is not given, but we want to find it. Then we can use the trigonometric functions for finding it. Let's suppose that the side y and the hypotenuse r are given. Then we can use the function sine of theta, which is equal to y over r, for finding the angle theta. We only need to use the inverse of the function sine, which is arcsine. If we do so, we find theta equals to arcsine of y over r. We can also use the function cosine of theta for finding the angle. We only need to know the side x and the hypotenuse, and theta will be equal to arc cosine of x over r. Finally, if the sides are given, meaning the opposite to the angle and the adjacent to the angle, we can use the function tangent of theta for finding theta. And thus, theta will be equal to arc tangent of y over x. We will talk about the inverse trigonometric functions in more detail in next lessons, but for the moment on, we're going to use it for finding the angles of a right triangle. Let us consider the following right triangle, which angle theta is equal to 60 degrees, and the opposite side is 7. Thus, if we want to find the adjacent to that angle, we can use the function tangent, and we know that tangent of 60 degrees will be equal to 7 over x. Thus, by solving for x, we know that x is equal to 7 over tangent of 60 degrees, which is equal to the square root of 3. Therefore, x is equal to 7 over the square root of 3. Now, if we want to find the hypotenuse of that triangle, we can use the Pythagorean theorem, and r will be equal to the square root of 7 over the square root of 3 squared plus 7 squared. If we simplify, we have the square root of 49 over 3 plus 49. Thus, r is equal to the square root of 49 plus 147 divided by 3. Finally, r is equal to the square root of 196 divided by 3. Now, let us consider the following triangle. Notice that this triangle is not a right one. Now, if two angles and one side are given, then we can use the law of sines for finding the remaining sides. Remember that this law states the following: sine of alpha divided by a, it's equal to sine of beta divided by b, which is equal to sine of gamma divided by c. Let us consider the following particular triangle, which is not right. we can notice that the given angles are 70 degrees and 35 degrees. Remember that if you want to find the angle theta, we can use the fact that theta plus 35 plus 70 is equal to 180. Thus, we can solve for theta and find that theta is equal to 75 degrees. Now, by using the law of sines, we can find the side x, knowing that sine of 70 degrees divided by 10 will be equal to sine of 35 degrees divided by x. And if we solve for x, we get that x is equal to 10 times sine of 35 divided by sine of 70 degrees. We only need to substitute for getting the actual value. Now, if we want to find the side y, we can use the fact that sine of 75 degrees divided by y is equal to sine of 70 degrees divided by 10. And once we solve for y, we get that 10 times sine of 75 degrees divided by sine of 70 degrees will be equal to y. Finally, let us consider the case in which we have a triangle which is not right, only one angle is given and two sides are also given. Then in such a case, we have to use the law of cosines. Let us consider the following triangle, which is not a right one. Then the sides x, y, and z are given, and the angles are alpha, beta, and gamma. Then, by using the law of cosines, we know that x squared is equal to y squared plus z squared minus 2yz cosine of alpha. But we can also use this for the remaining sides, and we will get the following: y squared equal to x squared plus z squared minus 2xz cosine of beta, and z squared will be equal to y squared plus x squared minus 2xy cosine of gamma. Let us consider the following triangle with the given angle alpha equal to 20 degrees and the sides 10 and 5, and x, which is opposite to 20, which is not given and we want to find by using the law of cosines. If we use this, we know that x squared is equal to 5 squared plus 10 squared minus 2 times 5 times 10 times cosine of 20 degrees. If we simplify, we have that x squared is equal to 25 plus 100 minus 100 times cosine of 20 degrees. If we perform this operation, 100 times cosine of 20 degrees, we get 93.96. Thus, x squared will be equal to 125 minus 93.96. Thus, x squared will be equal to 31.03, and if we square root both sides of the equation, we get the actual value of x, which is 5.57. Well, guys, this is all for today's lesson. I hope that you learned a lot from it. Now it is time for you to practice. Try to solve the following problems regarding finding sides and angles of right triangles and triangles that are not right by using the law of sines and the law of cosines, respectively. And as usual, guys, see you in the next lesson.